Hello all and welcome back. So in this video, let us now move forward and write the code for the question minimum cost path. Now we have discussed this already in the last video, and in this video, I want to make sure that we are able to write a recursive solution for the same. Okay. So as discussed in the last video, the problem is something like this. We are given a matrix which has a path overall we have to follow starting from 0, 0, and we have to reach, let's say, to mn or the bottom right. Okay, so the rightmost and the bottommost cell. Now normally we can do it either by incrementing this starting point or by decrementing the last point. I'm going to do it by decrementing our m and n. The reason, normally the other one is pretty easy, but I want to make sure that you are able to understand each and every approach. Okay, so the same will become a lot clear when I will write the code for this. It is based on our discussion only, so don't have to worry on anything. Now let's go back to the question statement, what we were given. So it was something like this. We are given a cost matrix. Now the shape is 3 cross 3, but because of zero indexing, we know that m and n will become 2 comma 2. Now you are passing minimum cost path recursive and m and n here. If we do it in other way, we have to normally pass I and j as well, which will be 0 and 0, right? So I'm just going to show you another approach through which we can avoid that. Okay, great. So let us now write the code for this, everyone. First, the base case, okay, which we will come back to. I think recursive call is something which we discussed. So let us write down the recursive call first, and then we will write our work and return the answer. Let's talk about the recursive call. We saw that how we have to make these calls in the last video if we are starting from here. Okay. All I am now asking you to do is just to solve it in another way through which it is a lot more clear as well. Let us, instead of starting from this position, let us start from the last position, that is m and n. Now, if we are starting from m or m and n, which is 2 comma 2, or any other cell as well, we have to make sure that we reach to 0 comma 0. Okay. Again, the other approach is easy, so please make sure that you understand these approaches as well. Coding and DSA is more about understanding different approaches as you code. Now the whole discussion stands as it is, just that I will be making 3 steps which will be in the different direction. Okay, so here my steps are left, then I have right, sorry, not right, my bad, left, and then we have top. Okay, so let me just remove this. Second after that is top, and third one is diagonal. Okay, everyone, so pretty sure this must be clear. Now for doing that, let us see what exactly we have to do. First is cost left. It's going to be equal to min cost path recursive, cost matrix as it is. If we are moving to left, row will remain as it is. M here is equivalent to row, but the column is going to decrease by 1, right? So in the right, row was remaining the same, column was increasing by 1. If I have to go here, row will be 2 only, column will become 1. So I have the cost from left, then cost top, min cost path, cost matrix. This time column will remain the same, but row will get subtracted by 1. So if I'm moving on top, column is 2 only, but this row will become 1. Okay. And the last thing is cost of diagonal, which again will of course be equal to cost. This time just subtracting both of them. Okay. So just I am starting from here and reaching to this 0 comma 0. Once I have this cost, what I have to do, everyone, I can just say answer equals cost of m and n where I am standing plus minimum. Okay. And I think Python minimum takes more than 2 as well. So we can just use it as it is, cost diagonal and cost top. Okay, so yeah, it's not giving any error. In many languages, it just takes 2 argument. So we have to call it multiple times. Okay, great. So I'm pretty sure till now everything will be clear. I have just tried a different approach, starting from here and trying to reach here instead of the other way around. Okay, the benefit, you can think that it help us to not pass ij as well, or the starting point as well. Okay, which we will be increasing. So I believe that it should be very much clear to use different approaches. Great. Now, once this is clear, let us talk about the base case. What if we start or we reach this particular position, the origin from where we have to start? I think we can just here return that, hey, where you are standing, that is your cost. Okay, so because both of them are 0, right? So let's say if I've reached here, or if I start from here only, then you can say, like, if it's a single element matrix, then again we can just stay here and get our work done. Okay, get the cost. Great. So all this is fine. But if you remember, we all discussed another approach in the another outlier in the last overall video, which is that what if I'm standing here? I cannot go to these directions, right, everyone? Similarly, when I start in this particular matrix, let's say if I'm standing here, I cannot go in these directions. And I'm pretty sure you will be able to see what are the constraints here. My m and n, they are becoming less than 0. And if I am going to less than 0, either I can stop that, either I can say that, hey, don't go here, or I can say that, hey, you are getting an infinite cost here. Everything outside of this matrix is infinity. Because we are solving for minimum cost, we can take infinity. In questions where you have to give for maximum cost or something, you can take the negative infinity. Okay, great. So let us see that, everyone, what I'm saying here. All I'm saying is if m less than 0 and n less than 0, we can just return float of inf, right? Something this we have already discussed in one of the questions, how this is the maximum number basically which Python allows, right? Infinity. So in other languages like C++, Java, we have int max or something. So again, you can take any very big number as well. That should be fine. And now I think we have handled all the cases. The other approach I was saying was something like this. So if your m equals 0, then we will be avoiding these two calls. We will not be making these two calls. Okay, everyone? So you can handle it like that as well, but it will give you lots of conditions. And my aim is to showcase you different approaches, and this is a smart approach. Let your overall matrix go there, that should be fine. But we can say that, hey, this is an infinite cost. And once it reaches here, let's say, then we will not make other calls because we are returning from here already. Okay. So yeah, I think this code should overall work. The answer should be, if we start from here 3, then the minimum is 2, then this is 2, and then 1 finally, right? So let us run this and get the cost. The answer should be 3 plus 2, 5, plus 2, 7, and 8. Okay, so it's giving us an error. Let us solve that. Recursion, okay, it's saying maximum recursion depth exceeded. Let us see why is that. Okay, so we have not returned the answer, right? So we have to return the answer as well. Okay, so still it is giving the cost maximum recursion depth is exceeded. Let us quickly see where exactly have we made an error. So we start from m equals 0, and if they are 0, then okay, so it should be or, right, everyone? Either m is less than 0 or n is less than 0. Okay, it is not and, because else the call will get keep on getting made. Just because we have less conditions here, it was easy to easily see that, yeah, this is where error is getting. And we have the answer. Minimum cost to reach 2, 2 using recursion is 8. Okay. So pretty sure this approach is clear to each and every one of you. Again, if we have to do it another way, you can take IJ. But I think this is a better approach and overall a smarter way of solving this problem. We are making sure that we are handling all the cases like this. We have the base case here as well. And all these are the recursive call which we will be making. And then you can get the cost here. Now, what I want all of you to do is, if you are not able to solve it, please try to write the code, recursive code yourself. Even if you were able to write the recursive code in a different approach when you start from 0, please make sure that you write this code as well at your end. Okay. Again, the basic idea is to make sure that you understand different approaches. So if tomorrow you see some other code which is being done by a different idea or approach, you are able to understand that as well. Okay. So great, everyone. If you are able to 100% understand this thing, then next step, we have to apply memoization here. Now, why we have to do that? Because if we see, okay, for this particular, let me just get this image. So for this particular matrix, we will be making lots of calls which are repetitive. How repetitive? Pay attention. When I'm here, when I'm on this 3, okay, I will make a call to these. But 5 will also make a call to 8, right? Then 1 will make a call to 4, but this 8 will also make a call to 4. Right, everyone? So you can see that how many calls we are repeating. For example, for 1, 2, 3, 4, 8, 2, 1, 5, 3. Now this 3 will make calls here. This 5 will make calls here. So we can see that, okay, 8, we are making multiple calls. And again, as the matrix will increase, these calls will just keep on piling up. And we will be making lots of calls. But I feel that we should have saved it somewhere that, hey, this is the maximum, this is the answer if I'm making the call from here. This is the minimum cost which I'm getting. Once you have saved that, I think it is very easier to not make those calls again. Now, this is very much different. Normally, it is known as two-dimensional DP because this is in some way, we are not dealing with a list or an element in a straight line here. We have a matrix instead. Okay. So to just give you the idea, what you can do here, you can play on indexes. Okay. So this time it will be different from all the questions which you have already, which we have done previously. This time we have to create a matrix or a 2D list. Okay. In this 2D list, we will be saving our answer like this. Now we are saying that, okay, we are starting from here. What is the cost if I start and end here? I think it should be cost of M and N. Each of this matrix, each point in this matrix will define cost to reach this point from M comma N. And of course, since we are dealing with the minimum cost, right, everyone? So we will get the minimum cost to reach this point from a point, from this particular point. This is how our matrix will be defined. Now I want all of you to first try this out once, because again, this question you will be doing, or you will be entering into this 2D DP domain for the first time. So I want to make sure that each and every one of you understand this thing, right? I have just flipped that we are starting from MN, not from 00. Apart from that, everything is same. Okay. In the next video, we are going to discuss that how exactly we will write a memoization approach for this code. So let's meet in the next video, everyone. Till then, please make sure that you try this question out again and now try to write or change your recursive code into a memoization approach.